All right, here we go. Question number 11 from our 1316 homework number 1 in MyLab Math. And we have a word problem. A gondola on an amusement park ride spins at a speed of 14 revolutions per minute. If the gondola is 22 feet from the ride center, what is the linear speed of the gondola in miles per hour? All right, so the best thing to do if you have a word problem and you need help understanding what's going on, if you can draw a picture, you want to draw a picture. So let's see if we can draw a picture here. Let's see here. Bam, bam. This is just a estimation of what's going on here, but it says a gondola on an amusement park ride spins. So I'm going to guess that this is kind of like a Ferris wheel where you may have gondolas, which is the carriages around the wheel, and they're spinning in a certain direction, okay? There maybe it's going counterclockwise and they're spinning around and they happen to be 22 feet from the ride's center. So from the center out to the gondola, notice that this is a circle, so that's going to be a radius of 22 feet. So we know at least that much. We know that this ride spins at a speed of 14 revolutions per minute. So if you're in one of these baskets or gondolas, you're going to go around this circle 14 times every minute. That is your what we call angular speed. So in the formula, if you notice something that looks like a W, that is actually omega, lowercase omega, and that is your angular speed. In order to plug into this formula, we need angular speed to be in radians per whatever the time unit is. In this case, it's minutes. So we're going to need an angular speed of so many radians per minute. What we currently know is revolutions per minute, okay? So let's make a note of this. Our angular speed, remember this is omega, is the angular speed, is 14 revolutions per minute. We want that angular speed to be so many radians per minute. We're going to have to convert that to radians per minute. So let me ask you a question. Let's say that I'm in one of these gondolas and I make a full trip around the circle. How many degrees did I go? Well, we know that there's 360 degrees in a full circle. That's one revolution. How many radians is that? Well, one revolution is 360 degrees, but that's the same as 2 pi radians, okay? So for every trip around the circle, we're going to travel a distance of 2 pi radians. So to convert to radians per minute, we want to take the revolutions, which in this case is 14, and we want to multiply that by 2 pi. And that is how you convert revolutions to radians, is you multiply by 2 pi, because every revolution is a 2 pi radian. So our angular speed is going to be 14 times 2, which is 28 pi radians per minute. Okay, so there's our angular speed in radians per minute. We also have our radius, and they ask us to find the linear speed. Okay, so if you think about what this might be in real life, let's say that you're in one of these gondolas and you're headed around the circle, and all of a sudden your gondola comes unattached from the ride. Are you going to continue to go around in a circle? No, you're going to take off in a straight line and you're going to end up on the ground, maybe injured or dead, okay? So anyway, now that we have the angular speed and the radius, we can now find the linear speed. Plugging into the formula, that's going to be the radius, which is 22, times our angular speed, which is 28 pi. And since that's going to be linear speed now, that's going to be feet per minute, because the radius was measured in feet and the time unit was measured in minutes. So that's going to give us feet per minute. And let's grab the handy dandy calculator and see what we get. So 22 times 28 pi equals 616 pi feet per minute. Or if we convert that to a decimal, that's 1,935 and some change feet per minute. Now what I notice that it wants it in miles per hour. Yikes. So we're going to have to actually convert our answer into the units they ask for. So what do we have? We have 616 pi feet every 1 minute. So that's kind of a representation as a fraction of what we have for linear speed currently. In order to convert that into miles per hour, we're first going to have to convert, let's say, minutes to hours, okay? So we know that there are 60 minutes in an hour. And the reason I put the minutes on top is because I want the minutes to cancel. So minutes on top and minutes on bottom, the minutes will cancel and leave me hours. And so now I've got the time unit I wanted. Now I need to get the length unit I need. So does anybody know how many feet are in a mile? 5,280 feet in a mile. And again, the reason I put the feet on bottom is because over here the feet are on top, and I want to get the feet to cancel. Top and bottom, the feet cancel. Notice that gives me my length unit that I was looking for, which is miles, okay? So now to get this converted or calculated, we're going to take our 616 pi, make a note of this, we're going to multiply that by 60 and then multiply it by 1, and that'll give us our numerator. And then we're going to multiply in the bottom 1 times 5,280, and that'll give us our denominator. Okay, so to start with, 616 pi times 60, that's our numerator, and we want to divide that by the denominator. So 1 times 5,280 is just going to be 5,280, which is 7 pi. And notice it does say an integer or a decimal. 7 pi is not an integer because pi is irrational. So we're going to have to convert that to a decimal. It looks like it wants it to 1 decimal place. So hitting the SD button, that gives us a length, I'm sorry, not length, linear speed of 22.0, and that's going to be miles per hour. And the reason I said 22.0 is if you round this to 1 decimal place, that 9 is going to see a 9 behind it and round up to a 10. So that actually rounds up to 22.0. Man, that was a long problem. I hope I got it right. Let's see. Fingers crossed. Man, I hope that was helpful. If you have any questions or comments, feel free to put them in the comment section below, or you can text me And thanks for watching.